Yes, sorry, I don't know why I said a password. So uh let me see if people can enter right now. Uh is it recording? So I think for today I'll write on whiteboard. Let me see. Do I still get notifications? Yes, I do. Okay, um so my name's Matthew. Can you all hear me? Yeah. You could type in the chat or just say yes or no. Okay. So my name's Matthew Chung. This is my email. So I'm a bit surprised that what do you call it? All lectures are like, I guess I know it's online, but it's like not live, right? He just makes the videos. So with that being said, uh, my plan is to talk about um, the topics related to homework first, so you can all get that out of the way, and then after that, we'll cover topics that maybe the homework doesn't cover. So, but before that, let me just say, unlike office hours, Math 2A 2B is a bit different. We have something called tutoring center. What's the date right now? So okay, so it starts next week Monday. I'll try to find what the Zoom link is, but start next week Monday. So it's like open like morning to like not evening but like afternoon. So so it's kind of better than office hours because office hours is like 1 to 2 hours a week. So this you could go every day, right? I mean it might not be us, we have shifts there, so it could be another math 2B TA, just sitting there waiting to help. So it's a bit better than office hours. It'll be online. Uh, I guess I don't need to tell you the location because okay. So and then mini quizzes. So I don't know if he discussed it with you. So these tests on the lecture videos. Uh, and then the quizzes will be like similar. I would say similar homework type problems. Um, okay, so yeah, so mini quizzes it should be easy. Like mini quizzes, like I set it to 25 minutes. It should really take you like 10 minutes. But note that these are one attempt, right? I would say around 25 minutes. So with that being said, make sure your internet connection is stable when you take these quizzes because it's one attempt. But since it's only one attempt, I could make the time span as large as one. So like so I for this so for the mini quiz, I made it last until like Thursday night. So you have like all the time in the world to like do it. Or yeah, because I know some people are in China and some are in like some other place. So the time gap really needs to be like at least 12 hours. Any questions regarding like, quizzes and stuff before we get to the material? Okay. So let's continue. So I'm gonna move on to the next whiteboard. Quizzes will probably also be 25 minutes. I mean, it shouldn't. I mean, I'm making it more than necessary. It should really only take you like 10 minutes at max. So you shouldn't be taking the whole 25 minutes, but just being lenient. Okay. So yeah, so there'll be out 10 points. So I mean, it'll be true, false, right? Either it'll be because it's online, right? So it'll be true, false, multiple choice, or like multiple answers. Yeah, so it should be pretty straightforward. So I think what we're going to talk about today is functions. So you can just think of this as like a map, I guess. It takes in an input and produces an output. So I'm just gonna go like, more like definition wise. I know the professor in the lecture video does like examples with like factories and stuff. So okay. So no, I say it takes an input and spits an output, right? So if these are like inputs, so later it's called domain. But like, if it takes one input and spits like an output. So this is the range. Like basically it's only for every input there's only one output. Yeah. So you can't have this. So you can't like f of this element right here cannot be two different things. Yeah. So it's possible for, this on the other end can happen. So you can map to the same output, right? But you can't have like an input mapping to two different outputs. So that is not a function. Okay. And pictorially, it's just vertical line test, right? So, because if you graph it, I mean, just think about it like a circle. So for a circle, right, like the input here maps to two different outputs, right? That's a no-no. Yeah. So like this graph of a circle is not a function. Okay. Now, moving on. So I guess the first thing on your homework, it would be, describing functions. So I guess the first thing on your homework would be like even and odd functions, right? So let's go over what even functions are. F of negative x is f of x. Yes, so, and this is for all x domain of f. Oh, sorry. Most of you might not know this notation. For all x in domain of f. Now, right, so examples of this is f of x is x squared. Yeah. Because f of negative x, which is negative x squared, this is just x squared, which is f of x, right? So, right, and you can see, I think on your homework, you using this law, you could figure out values of, given the value of a function, the value of something else, right? Like if like in this case, f of 2 is like 4, right? I mean, without even knowing the function is x squared, right? If you just know f of 2 is 4, using this law, you know f of negative 2 is f of 2, which is 4. So you know the value at negative 2, just from the fact that if they tell you the function's even. Yeah. So, and a way to think of this is it's sort of symmetric about the y-axis. Yeah. So, and I think they call it even because, you know, all even power. I'll just say all power functions that are even power. Power functions that are even power are even. So, you know, like x squared, x to the 4th, all of these are even, right? Because like when you raise a negative number to an even power, it just becomes positive, right? So, okay. So note that, you know, not, I guess I want to say not like, these aren't the only examples, right? Like, you know, is not just power functions. So other examples are like, I think cosine, yeah, cosine's even, right? You could check this because cosine is like this, right? Right, you see it's sort of symmetric about this y-axis. Okay, so similarly, let me move on. You can all see, right? Hopefully. Type yes or no, or just tell me. Yeah, okay. So odd functions are exactly the opposite. So f of negative x is negative f of x. Now, I mean, this, you know, is as you think. Its examples are the odd power functions. So x cubed, x to the 5th, x to the 7th. I don't know why I put the 3 first. Like, you know, so on and so forth, right? And again, you know, you have something like sine. Other examples include sine is like odd, right? Because if you think about it, just for example, you know, sub example, like sine of pi over 2 is 1, but sine of negative pi over 2 is what? That's negative 1, which is negative sine of pi over 2, right? You see? So sine is an odd function. So, I mean, if you just think of, right, so it's sort of like, you're sort of like reflecting about the line, you know, y equals negative x, I think. So, how do you graph sine? Yeah. Oh no, what am I doing? Yeah, so like, you know, you're sort of this point matches with this point matches with this. So you're sort of reflecting about the origin, sort of, yeah, you know. While the even functions, you're sort of reflecting about the y-axis. So again, like if I just tell you the functions, if I tell you like f of 100 is like f odd, f of 100 is 1,000, right? You know what f of negative 100 is using this law, right? F of negative 100 is negative f of 100, which is negative 1,000. I think that's what the homework is like asking you. So, okay, so do be careful. Unlike, let me just write, unlike even / odd numbers, right? Like a number, is either even or is odd, right? You have no other choice, right? A number, if you choose any number you like, or I guess integer, sorry, integers, right? And an integer is either even or odd, right? Like 3 is odd, like 2 is even. The even slash odd functions is not one or the other, right? So what I mean is there are functions that are obviously you can't be both, right? From this definition, but it's possible you're not even and you're not odd. So not one or the other, right? An example would be, let me think. Yeah, so f of x is, let's say 2 to the x, right? So let's check whether it's even. So if it was even, f of negative x is f of x, right? For all x. So, I mean, in particular, let's just choose a number. F of negative 1 better be f of 1. But what's f of negative 1? That's 2 to the negative 1, which is a half. F of 1 is 2, sorry. So you see that they're not equal. So from this, it's not even, right? And to check it's not odd, you just need to check this is not the case, right? So I mean, just plug in a number. In particular, f of negative 1 has to be negative f of 1. But as we checked, f of negative, I mean, I'm not going to write again, but from here, it's clear that negative 2 is not a half, yeah? So it's not like one or the other in the case of functions. Everyone clear so far? Okay. Let's move on. So again, for the recordings, I'm still thinking of whether I should, I mean, I'm going over the same thing for the afternoon. So I'll either post like the morning lecture video, I mean, discussion video, or the afternoon. I'm not going to post both because it's like the same thing. Okay, so composition. Composition of functions. So this, can we go over e to the x, please? Is there something you want to know about e to the x? Or so, I mean, just like, you know, just like my example, 2 to the x, I mean, it's something similar, right? I mean, e is just some number. It's like 2.7, whatever, right? So it's just, e to the x is just some number to the x power. Oh, okay. Yeah, if we have time, I'll get to that, yeah. Or I'll get to it on Thursday if you like. Okay. So composition of functions, right? So what does it mean when we say like f compose g? Right. This just means this. Now, a lot of you might be confused. Like, what is this? Well, you've seen it before, right? Because if I told you f of x, let's just do an example. F of x is, I don't know, x plus 1. G of x is, yeah, let's use e to the x. so in this case, right, before we solve this, I want to ask, what is f of 1? Can anyone tell me what f of 1 is? And yeah, it's 2. How do you get that? You plugged in 1 for x, right? So how do you get this? You plugged in 1 for x, right? So similarly, f of g of x, well, what is g of x? It's f of e to the x. Well, just do the same thing, right? You plug in e, instead of plug in plugging in 1 for x, you plug in e to the x for x, right? So I plug in e to the x for x here. I get e to the x plus 1. Yeah? I mean, you've done it for numbers. Composition just means you're doing it for functions, right? So something like f of x is what? It's f of x plus 1. So again, you plug in x plus 1 to x. So I get x plus 1 plus 1, which is x plus 2. Yeah. So let's do this first example. Let's do another one. I don't know. 2x plus, let's do 2x plus 1. G of x is sine of x. So do be careful here. You know, you're replacing x with x plus 1, right? So here I'm not adding 1 to like x. So what I mean by this is, why do I have eraser? Okay, this is f of 2x plus 1, right? So here I'm plugging in 2x plus 1 for x, right? So this is 2 times 2x plus 1 plus 1. Yeah? And then you FOIL. So what do you get? 4x plus 3. Yeah? And then let's just do 2 more. So f of g of x is f of sine of x, right? So I'm plugging in sine of x for x, so I get 2 sine of x plus 1. And vice versa. Here, right, it's g of 2x plus 1. So I'm plugging in 2x plus 1 to x, so this is sine of 2x plus 1. Yeah. Is everyone clear on this? Okay. So I guess the next thing would be, the next thing I see, I mean, I can't cover everything today, but hopefully I cover most of the stuff. So next thing is domain. Yeah. So just think of this. If I give you domain of f is like all possible x values. Yeah. That's the way you should think of it. So no, this is not formal, informal definition, but that's the way you should think of it, right? So I think the best way to explain this is just do examples, right? So f of x is square root of let's do something easy first. X minus 5. So the thing when they ask for domain, the thing you should ask is what are the possible x values you can take. So x minus 5, let's look at x minus 5 first. So without that square root, x minus 5 is perfectly fine, right? Like you could plug in any number and you get a valid answer, right? So the square root is the issue. So what values can square roots not take? Yes, it could take 0, right? So this is easy. I just want this to be bigger than or equal to 0. So because square root of 0 is 0, so x has to be bigger than or equal to 5, right? So I don't know. I'm not. So here's the thing with WebAssign. I don't know how WebAssign wants this. Like if they ask you this, do they want it like this? Another way to write this is bracket 5 to infinity. I'm guessing they would ask for interval notation, but let's do something. Maybe let's do something different. So square root. Oh, okay. Yeah, just write interval notation. F of x is square root x squared plus 4. Okay, so I'm gonna help less. Let me ask the class. What do you think the domain of this is? Yeah, it's everything, all real numbers. Because the only problem here is if x squared plus 4 is less than 0, right? So we want this to be bigger than or equal to 0, but this is always this is like always the case, right? Because you don't even need to check this because this is positive and this is positive. So in this case, right, no issue occurs. So the domain is like, yeah. See, I think if they wanted interval notation, I'm guessing they want you to write it like this. I'm okay if we just put R. So okay, let's move on. So let's do f of x is fifth root of e to the x. What do you all think this is? Yeah, all real numbers, right? So first you ask yourself, does e to the x have any problem? And it certainly doesn't, right? I mean, you could raise any number to whatever power you want, and that certainly doesn't cause any issues. So the fifth root also doesn't cause any issues. You could take a fifth root of any number, right? Even negative numbers, right? Like, I mean, just think of cube roots, for example. Like cube root of -8 is -2, right? So certain like taking like odd roots certainly doesn't cause any issue. So you have this. Okay, let's do last one. Let's do x minus 2 over square root x minus 5. So let me just number this. Yeah. So from example 1, you already know the domain has to be at this or something smaller, right? The fact that you have square root x minus 5, you already know the x values have to lie in here, right? The only question is, do we have to exclude more, right? So whenever you see a fraction, right, what can go wrong in a fraction? Ren is like a fraction, like not defined, right? Yeah, and the denominator is 0, right? So when this is 0, we can't have that this is 0, right? This is a no-no. And if you solve for it, you're going to get x is 5, right? So when x is 5, it's a no-no. So you see that the domain in this case is parenthesis 5 to infinity. Yeah?
Yeah.
So there's two things going on in example 4. We can't square root negative numbers, and we can't divide by 0. Yeah? Is everyone good so far? Yeah. Okay. Let's move on. So I guess the next thing okay, so this is from like me skimming through the homework questions. Hopefully I'm covering most of it. So one-to-one functions. So there's like a really, honestly, I think that the picture way is easier to see. It basically means that every output has at most one input. Let me just put it this way. Has at most one input. Yeah, so like an example of something that's that's one-to-one is like, you know, this maps here, this maps here, right? Because it's possible, right, for something like this to happen, like I showed last time, right? For two inputs to map to the same thing, right? And that cannot happen for one-to-one functions. So one-to-one functions are nice. So another way to see this is I think the actual definition is if f of x equals f of y. I guess people don't like y, huh? Because they use. Let me just use f of x1 as f of x2. Then x1 is x2, right? So if f takes a point to like some output and another to the same output, then these two must have been the same, right? So you see in this case, it's not injective because let's call this x1, x2, right? Here, let's call this y1, right? So f of x1 is y1, f of x2 is y1, but x1 is not x2 in this case, right? I mean, picture-wise, they're two different points, right? So, yeah, that's so another word for this, for people who might not, another word for this is injective functions. Injective. So here's a cool thing. If I have four elements in my domain, and then 3 elements here, right? And let's say f is a function, right? F maps these 4 points to whatever you choose, these 3 here. Can f be injective?
No.
No, right? Because I don't care where you send, you know, I don't care, like this one, let's say it goes here. This one, let's say, I don't know, it goes here. This one, let's say it goes here. For that 4th point, it has to go to one of those 3, right? you have no choice. I mean, assuming that's what the range is. So you see, like this has to, you know, if it goes here, it's non-injective. Goes here, it's non-injective. Goes here, it's non-injective, right? So so if you're interested, injectivity sort of tells you something about like the size of domain and ranges, but that's for people who want to get into further math. But for us, that's good enough, right? So examples, right? F of x is x cubed, right? So if you graph, this is how you graph it, right? Something like this. And if you know the graph of the function, how you check it's one-to-one is horizontal line test. So kind of like how we did the vertical line test, right? To check whether something is a function. Horizontal line test checks whether it's one-to-one, right? So it basically says that for every horizontal line you draw, it can only intersect your function at I guess, yeah, one point, at most 1 point. So let me just write non-example. I'll just go one power less. F of x is x squared, right? This is like a parabola. You see it fails the horizontal line test, right? Right, because in this case, it's saying if this is the definition, if you want to go by definition, then that we could just say f of 1 is 1, f of -1 is 1, right? So certainly we're in the situation of can I make this colored? Oh yes, I can. So if we're in this situation, right, where f of x1 is f of x2, right? But then that would mean 1 has to equal -1, right? Which is not the case. And you see in this case, injectivity, I mean, one-to-oneness fails like almost everywhere, right? Fails at like every single spot above the y-axis, above the x-axis. So, any questions so far? Everyone good? Okay. So let's move on. So I guess no, all but one-to-one means is an injective is like the same thing. uh, it's just another way to say it. Yeah. I guess just ignore the word injective. I guess since I don't think the book ever really defines that. Did they? Yeah. For just know one-to-one means like if f of x equals f of y, then x equals y. Yeah. So I guess the last thing, I mean, not last thing, but I think this is like the last part of your homework. Inverse of a function. So what is the inverse? Yeah, so the first thing is what is the inverse? Well, let's do a picture first. So I'm gonna label this 2, 3, right? And I don't know, 4, 5, 6. So if one, let's say f takes 1 to 6, 2 to 4, and 3 to 5, yeah? From here, what does the inverse do? It's exactly what you think, right? So if f maps like x to y, the inverse maps y to x, right? So from here, you know that f inverse of 4, since f maps 2 to 4, f inverse maps 4 to 2. And since, what was it? Since f maps 1 to 6, f inverse of 6 is 1. And f inverse of 5 is 3. So certainly you need the function to be one-to-one, right? I mean, for a not every function has an inverse. So the reason for this is an example would be like, x squared. So because if you think about it, right, like I'll just start with this. So let's go 4, 5, right? If 1 maps to 4, 2 maps to 5, let's say 3 maps to 4, yeah? Then what's f inverse of 4? Do you all see like why that's a problem? It's because, right, if f maps like x to y, f inverse must map y to x. But the problem right now is, right, like does 4 get mapped back to 1, or does 4 gets mapped back to? Yeah. I mean, yeah, you need to be one-to-one to have an inverse. So I guess to make things clear, right? Remember how I told you the function f of x is x squared is not one-to-one, right? The problem is that you have two choices, right? The 1 and -1, right? So you have the choice for f inverse. Is it root x or negative root x? that's like the choice you sort of have to make, right? Because like here, right? F of 1 is 1, f of -1 is 1. So what is f inverse, right? F inverse of 1, right? Is it 1 or -1? Sorry, I'm writing. I ran out of room. But right, if you say it's 1, then f inverse of x is root x, right? Because f inverse of 1, I mean, square root of 1 is 1. If you say it's -1, then it's this, right? Because negative square root of 1 is -1. So you sort of see there's like there's an issue, right? The inverse is not really well defined, right? Because you have a choice to make, is what I'm saying. Is everyone good so far? Everyone understand? Like, at least, I'll go over the, how to find the inverse, but I just want everyone to understand like what the inverse is, right? Because once you know what the inverse is, the homework question becomes like super easy. So, like let's find the inverse of y equals x cubed, right? So how would you do this? Well, what does the inverse do? If f maps x to y, so f inverse maps y to x. So you're sort of swapping x and y, right? So just swap x and y. X equals y cubed, and then solve for y. So y, whoa, sorry. Can I go back? Yeah. So x equals y cubed. So solve for y, you get y is cube root of x. That's your inverse, right? You see the problem with doing it for the x squared is when I swap x and y, right? X equals y squared. When you solve for y, when you square root both sides, you get y is plus minus root x, right? And that's where the problem occurs when you try to find the inverse, right? Plus minus root x is not a function, right? I mean, square root x is a function, minus square root x is a function, but plus minus is not. Yeah, in this case, it's nice. I mean, when you solve x and y is isolated. So I think, I'm not sure, I forgot, but in your homework, right, when you swap x and y, maybe you would, I think they gave you like a fraction or something. I forgot, but like you basically solve for y, right? So you would cross multiply, put all the y terms on like one side, and then solve for y. So yeah, but that's the idea. So if you ask why you're swapping x and y, it's because it's this. So it's definition of inverse, right? Everyone clear so far? So so I guess let me move on. I guess last thing, since you want me to go over transfer, I guess I could get started with transformation since like okay, so how can I make this fast? I think the better thing to do is, let me just show you how to graph it. So when you replace, let me just say, if I start with a function f of x, if you replace like f of x by x minus, so you need a convention, yeah? So like, let's say a is positive, yeah? Because I mean, if a was negative, it would just be x plus a, where a is positive, right? So replace with f of x with f of x minus a. So what are you doing? Yeah. So let's do an example. F of x is, I don't know, x, right? Let me just say x. So if you replace it with x minus, this is a bad example. Let me think. X cubed. So if you replace f of x with x minus 4, yeah, so a is 4, right? If I replace this with this, how does the graph change, right? So you see here, right? This is the graph of x cubed. So now, I mean, if you just think about it, where's the origin now? So at what point is this 0? It's when x equals 4, right? So you see that the graph looks somewhat like this. Yeah. So you can see, I mean, you just test examples, right? Shifts a units to the right. and then hopefully you get the same thing for like the left. So x plus a shifts to the left. So let me just write plus a shifts. Due to time constraints, I'll just put plus a shifts to the left. Yeah. While minus a shifts to the right. And similarly, you could ask yourself, what if I add a? Well, I mean, just do it for this example, right? And what you're going to see is, well, at 0, it's 4. So before at 0, it's 0. Now at 0, it's 4. So you can sort of see it shifts you up. Yeah, shifts. I'll go over like compress, and I don't think compress and condense matters, because like in terms of the graph, I mean, it just shrinks it and stuff. But I think the important stuff is knowing shifting, because that really changes like the graph. So shifts 4 units up, and then similarly I'll just write minus a 4 units down, right? So I mean, I didn't really look at the transformation questions. I guess I skimmed over that. But let's say f of x was, let's do an example. I mean, sure, let's do that. Let's do let's graph e to the x. I mean, I'll just do shifting for now, and then I'll go over the rest next time. But like, let's graph this, yeah? Is that fine? Or let's do minus 7. So what I would do is I would graph f of x as e to the x first. So do you all know how that looks like? It looks something like this, right? Because at e to the 0 is 1, right? So at 0, this is 1. And then, it goes up. So I would graph this first. And then, how am I going to get to this? Well, I'm going to replace it with x plus 5, right? F of x plus 5 is e to the x plus 5, right? Everyone agree? So this is, if you remember, it's composition, right? I went over that like 40 minutes ago. You replace x plus 5 with x. So what does that do? I mean, just go to the rule, right? Right here, it shifts 5 units to the left. So you move 5 to the left. So I guess it now looks like this. Yeah. Now you say, okay, I'm replacing this function, f of x plus 5. How do I get this? I subtract 7, right? This is equal to e to the x plus 5 minus 7. So what did I do? So what does minus 7 do? I shift 7 units down, right? So I take the previous graph, because that's what f of x plus 5 is, and I shift 5 units down. I mean, 7 units down. So, I mean, this is at 1, so it should be somewhere here. So that's the graph of e to the x plus 5 minus 7. I just find the original form, right? Because this pretty much looks like exponential with some transformations, right? So start off with exponential, and then just work with each transformation, right? Just apply the rule, like step by step, and then you should get the graph. Is that clear? Or hopefully, did I make that clear? Okay. Okay, cool. So let's call it a day. Yeah. And then I'll see you all on Thursday. No problem. Sure. What question do you have? I mean, so quizzes you just take on Canvas, right? So I suggest you don't use calculators, but like, I can't check whether you use a calculator or not. But let me just say this, like the quiz questions do not require, I mean, you shouldn't need a calculator to solve it. Yeah, let me put it that way. The numbers should be pretty nice. Nice and simple. So if you were in the classroom taking the quiz, I would not allow calculator. But like, I mean, in theory, I can't check, right? I'm not gonna go to your house and check whether you use the calculator. But the questions should be easy enough. I mean, I make it, so the questions should be easy enough to the point where, you shouldn't need a calculator. Uh, okay. Yeah, again, I don't know why they made a password for the room. Sorry about that. Because, like, I think Zoom automatically makes it. Okay. See you.